Hello, today we're going to consider this interesting problem. Let's read the question together. A block of mass of 2 kg is on top of a block of mass of 8 kg. Right? So 2 kg mass is sitting on top of an 8 kg mass. The coefficients of kinetic friction between M1 and M2 and between M2 and the floor are 0.2 and 0 respectively. So this coefficient of friction between these two surfaces is 0.2, and between the floor and the bigger block is 0, meaning this is frictionless surface. Find the acceleration of m1, this mass, with respect to the floor. Okay, so first, before we do this problem, let's consider what are the forces that's gonna act along this direction on these two blocks. Well, there is some sort of a friction force here, and this is pretty much it, right? So let's draw this and let's consider only mass 1. So you have your block 1 here, and you're pulling it with 12 Newton force, and there is a friction force that's going to oppose to it, right? So we're just considering this block. So what is the friction force between block 1 and block 2? Well, friction force between 1 and 2 is going to be equal to coefficient of the friction between these two surfaces, which is 0.2, times the normal force exerted by block 2 on block 1, right? So it's just the weight of the block 1. So if we calculate the friction force, it's going to be coefficient of friction times m1 times g, which ends up being 4 newtons. Okay, so what is the net force on the block 1, right? So we want to find out the acceleration of the block 1. Well, to do this, let's look at the forces that are acting on a block 1. So F is pulling it this way, right? This is shown in here, and friction force is pulling it backwards. So net force is going to be F minus a friction force, which is 12 newtons minus 4 newtons, comes out to be 8 newtons. Now, net force on the block 1 is just equals to mass, its mass times acceleration, according to the Newton's second law. And if we calculate the acceleration here, we just divide 8 newtons by the mass of the block, and it comes out to be 4 meters per second square. But be careful, this is not the acceleration that we are asked for. We are asked for the acceleration between m and the floor, right, with respect to the floor. So we found the acceleration with respect to this surface, right? So what if this block is moving and it's accelerating or decelerating? Then we have to add or subtract the acceleration of this one to find the acceleration of this block with respect to the floor. Well, let's look at what are the forces acting on the block 2. Well, see, when the friction force is pulling this block here, it's effectively the same thing as this block being dragged by the same amount of the force. So this block will experience a force, friction force, which is going to be equal to the friction between surfaces 2 and 1, right? So it's just going to be opposite. So it's going to be pulling, dragging it this way. So you're going to experience a 4 Newton force in this direction. And again, this has to be equal to mass times acceleration, right, of the second block. So the acceleration of the second block is just going to be friction force divided by its weight, which comes out to be 0.5 meters per second. Well, if this block is accelerating with an acceleration of 4 meters per second square to the left, and this block is accelerating with acceleration of 0.5 meters per second square to the left, then the acceleration of m with respect to the floor is just going to be the sum of these accelerations, which is going to be 4 plus 0.5, and it's going to come out to be 4.5 meters per second. And that's the answer. Thank you.